Uh, a very good afternoon to you guys. Today we are going to look at an inclined plane. These are other types of machines. Okay. So the other machines that we want to look at are number one, with what is known as an inclined plane. Okay. Now, what is an inclined plane? An inclined plane is it's a steep slope like this, which is used to reduce effort when carrying a load. Okay. So if we push this block, we are actually lifting it at a certain angle theta. Okay. So the more we push it, the more height we push. All right. Up until it's here. Okay. So the smaller the angle, the smaller the effort that is required. So this is one of the other machines that is used to reduce the effort. Okay. We move to levers. Okay, a lever is a type of a machine where there is load in the middle. Load will be in the middle. Okay? So, in the setup of a lever, it will be effort, load, then pivot. So it will be effort, load, then pivot. All right? There are basically three types of lever. This one with effort, load, pivot. For example, wheelbarrow. Okay? The wheelbarrow, it has got effort, the wheelbarrow is something like this. Okay? So ukundokune kune my hands. That's effort. Yeah. Then the load will be here at the middle. Okay? And this one kune viri ndokunenge kune pivot. Okay? So we have basically three types of levers. This one with effort, load, pivot. Then the other one has got pivot, effort, load. So the other type has got effort, in the middle. Okay? Now, the one with effort in the middle will work like this one is the one that we have effort in the middle. So how it functions, it's just a matter of we can have so many examples. So we are saying, let me draw a bracket, pivot, effort, load. Pivot, effort, then load. Okay? So we have got pivot, then we have effort and load at the end. So an example would be a hammer. Okay, a hammer is something like this. So the effort will be here at A. Sorry, with the pivot then we have the effort and we have the load. Then the last one is the pivot in the middle. Now, for pivot in the middle, it will be like effort, pivot, load. Effort, pivot, load. Okay? So these are basically the three types of levers that we have. Now we move to pulleys. Now, these are grooved wheels mounted on a block, and a rope passes through the groove, and it is used for changing the direction and size of an effort required. So we've got about three types of pulleys. Basically, we have three types of pulleys. Okay. The first one, which is number one, is called a single fixed pulley. Single fixed pulley. Okay. Now, for a single fixed pulley, it is something like this. It will be something like this. So what we have, so this is the pulley. And this is the string. Then this is effort. Effort E. Okay? And this is the weight of the load. Weight of the load. And the one that is going up is tension in the string. Okay? So this is an example of a single fixed pulley. So the mechanical advantage, MA, and velocity ratio, VR, will be equal to 1. Okay? So this one, it's more efficient than a single movable pulley. The effort is slightly bigger than the load because there is always some friction to be overcome. Okay? So that is it for a single fixed pulley. Now we move to single movable pulley. Now, for the single movable pulley, it is like this. This is the force. So the velocity ratio here is 2 because the rope must move twice the distance moved by the load as the pulley moves. Okay, so that's the reason why I was saying this one is not as efficient as a single fixed pulley. So it is a pulley on which the load is attached and the pulley can be moved. Okay, now we move to the last type of pulley, which is called the block and tackle. Block and tackle has got a okay. So this is the rope. This is the block. This is the tackle. This is the load. Okay, so we have this is the a thingy, a block and tackle. Okay, so this consists of 2 blocks, each with 1 or more pulley mounted on the same axle. Okay, so one block is fixed and the other one is movable. Each fixed pulley simply changes direction in which effort is applied, and the movable block increases the mechanical advantage of the system. Okay, so the more the pulleys, the easier it is to lift the load. That's the reason why you see kuti mukaenda kuma mechanical industries kunenge kune mapulleys akawanda, because the idea is shifter load becomes very easy. So the moving parts of the pulley system must constantly be lubricated in order to reduce friction, especially in this case whereby we are having so many pulleys. Okay. Now we move on to gears. Okay. Now, what is a gear? So, gears are simple machines. The gear system will consist of cog wheels mounted on an axle shaft or shaft. So, effort is applied on one gear, which in turn drives the wheel carrying the load. So, when the gear lever on a car is changed, the rate at which the engine turns, the drive shaft also changes. Okay, this is what happens with gears. Now let us look at low gear. Okay, now the effort wheel is smaller in the low gear. The effort wheel is smaller than the load gear wheel, and the effort gear has to be turned several times for the load gear to turn once. Okay, the velocity ratio in this case will be very high. So we are saying the effort gear is to turn as many turns as possible just for the load gear to turn only once. This is because the car will be having much load. That's the reason why you see kuti motikari inosumuka low gear, inokwidza makata low gear. All right, then let's look at the high gear. Now what happens with the high gear? Now the wheels are the same size, both the effort gear, the effort wheel and the load wheel, and it only takes 1/10 of the effort wheel to turn the load wheel. So in high gears like number 4 and number 5, in fact from number 3, 4 and 5, you would see the wheels for the load gear and the effort gear are the same. So 1/10 the effort gear is also 1/10 on the load gear. So understand this, if the load is now lighter, the car is now in motion. Okay, yakufamba momentum. That's when you can actually engage these gears. So thank you very much for watching. I hope you have enjoyed this tutorial. If you have any questions, don't hesitate to let me know at 0784 002 002. And also don't forget to like and subscribe on my YouTube channel. Goodbye.